Okay, I want to do a quick video of my Don Smith prototype. After studying the photographs and reading for a while, I figured out the schematic, and this is what I came to the conclusion of, and I put together, and it works. So then I wanted to go over how I got that. Basically, here we go. This is going to be your incoming 120 volts. On his system, it comes off of an inverter. It goes from a variac, which is a variable transformer. Then it powers this neon sign transformer, which ups the voltage and the frequency. The voltage is 120 volts coming in off of the variac, or anywhere from 0 to 120, at 60 cycles per second of oscillating alternating frequency. And the neon sign transformer ups that alternating frequency to 35 kilohertz at about 9,000 volts. So he has the one side of the alternating current connected to the ground of the neon sign transformer, which will be his negative. He has the other side. Use this diode to rectify the positive to charge the one side of his extended Tesla bifilar coil. He actually runs two diodes here, just because two diodes will, increase the voltage that he's getting from this, just to make sure he doesn't wreck anything. Then he has a capacitor on the videos. You will see he has a impedance matching capacitor, which comes from his. It actually comes from his negative line to his positive line over here, and it's just a capacitor right in between here. A nice high voltage capacitor will work to spark the circuit. And then he has his bifilar coil made, and I believe his spark gap is somewhere over here on the other side of the Tesla bifilar coil. The pickup coils are, in his case, they were aluminum flat wire. In my case, they are copper, but he uses aluminum flat wire, and he winds 17 turns with a center tap, and then 17 more turns. And he uses there's a capacitor right in here on one side of the coils, and there's two high voltage diodes to rectify the voltage, or the oscillating frequency, or oscillating voltage inside these pickup coils, to rectify his high voltage capacitors. The Don Smith device originally uses 4 2,000 volt capacitors, and they believe they were each like a couple farads, so they were large capacitors. And then the center tap will be going to the ground, or the negative on the capacitors, and that is how the system works. So here is the version that I'm going to show you. This is the exact same setup, basically. It's just a little bit differently. Instead of using the neon sign transformer and the variac, we are using just 120 volts off the wall, but we can actually run that off of an inverter the same way he did if we want to. And then we use that CFL circuit to drive our CRT flyback, our cathode ray tube transformer for the CRT. And that has a high voltage diode in it, which rectifies the voltage at a very high voltage with a positive and a negative. This pin is the negative. And then we have our homemade capacitor. This is a small foil wound capacitor. And then we have our spark gap, and it is hooked up just like this. This is our extended Tesla bifilar coil. I'll go over that in a moment. Here's our pickup coil. Our pickup coil is the same way that Don Smith does it in his resonance devices. We use 16 turns of copper wire, all in the same direction with a center tap. We have a high voltage diode on each positive, and that goes to our positive on our capacitors, and our negative goes to our negative on our capacitors. That is my version of the extended Tesla bifilar coil resonance. Let me elaborate here a little bit farther on the extended Tesla bifilar coil, and then I will get right into it. This is how the coil is wound. If you want to look at that, this is a little bit more of how it works. We have 2 sheets of aluminum foil. I just used some wire that I straightened out, and then put 2 on one side, 2 on the other. You separate them with plastic painting sheets for dielectric, and then you roll them up like that around a tube, and basically what you have is your bifilar coil. Okay, so that would be this one right here. So then you can see your points. Your spark gap comes from C and goes to D, and then your in is the other way. So that's how that works. I'll show you how the system works. Turn it on. Our incoming amperage will be on here, which should be, the incoming amperage should be about 0.04 amps at 120 volts, which will be 4.8 watts, right around 5-6 watts. This is a 10 watt circuit, but it's not actually using its full 10 watts. So that's what's going to be driving the flyback transformer. So there's our compact light. This is our homemade foil wound capacitor. It's pretty small. There's only 3 sheets of dielectric in there, so in case something was to blow, that capacitor will go before my coil. There's our spark gap for our circuit. Oops. There's our spark gap for our circuit. Our pickup coil, our Tesla bifilar coil, is in the middle there. We have our capacitor, and so this is the exact same setup that they use basically. And I'll plug it in and show you here. At the end, this is our out numbers. Our numbers are 50 volts or 500 volts. 500 volts at 0.2 amps. So that's approximately 100 watts of outcoming energy, and the incoming energy is about 5 watts. So here, we'll plug it in, and see, we're getting about, there it is, 0.04, and we are up to 400 volts. We're at 0.4, and we're running 0.4. We'll put the multimeter on the outside, and we are getting, there, we're up to 0.3. Okay, so we're at 0.3. We're a little over 100 watts on the outcoming side, and we are sitting solid at 476 volts. So there you have it. There's the Don Smith high voltage resonance over unity transformers at work. We're putting out, yeah, so 300 milliamps at 470 volts is our out, and our in is 0.04 or 40 milliamps at 120 volts. And that's the over unity transformer.